Hello, I'm Dr. Harper. This video is an exam study guide in the management of operations. So let's bring up the guide. Okay, the exam study guide for 6630 will be multiple choice, timed, open book, open notes, designed for evaluation. No collaboration, no internet. Now you can use the internet, but only for the material in this course. You can't use the internet to get information outside the course from other people. Each student must take their own exam. The exam will be over 4 topics, 15 multiple choice questions, 2 points per question, 60 minutes, no exam accepted after the end of the course. Okay, so general exam information. Online examination designed for evaluation will be given in the course. The exam may be taken only once. Exam will be open book, open notes, and timed. No collaboration is allowed. Collaboration is cheating. No communication with any outside agent is allowed. No sharing of material or equipment is allowed. And if academic dishonesty occurs on the exam, the student will receive a 0 for the exam, and any incident of academic dishonesty may be reported to the Internal Affairs Committee of the business school or to the university. Answers to the exam will be posted online. Exam grades will be posted on Canvas. Course grades will be reported to the registrar and will not be posted on Canvas. Now this is in general. Answers to the exam will be posted online in general, but sometimes I may not post them till after the course is over. It depends on the course and the section and what section we're in. The exam design. Exam questions will be approximately distributed over 4 topics. Forecasting is 4 questions, linear programming 3, aggregate planning 4, and the inventory 4 questions. And I say approximate because sometimes information on one question can help with another question, and everything's interrelated. For each question, this guide will describe the material and type of question that will be asked. Since the exam is open book and open notes, purposes of this exam guide are not only to review the material, but also to know where to find the material for the answers in your notes. Some questions will be qualitative and some will be quantitative. Therefore, a calculator will be helpful. Also, the wording and values in the actual exam questions can vary from this guide. Can vary. Actually, it will vary. Everything won't be exact. Okay, let's get into it. Okay, first of all, forecasting, 4 questions. The first question is based on the relationship between the components existing in the time series and the preferred forecasting technique. For example, random component only indicates moving average exponential smoothing. Random and trend is regression. Random and seasonal indexes. And these can also be combined, like regression and seasonal indexes, if you have a trend and seasonality. Question 2, based on the mechanics of the relationship where the seasonal forecast equals the seasonally adjusted forecast times the seasonal index, there are 3 numbers here. Use this equation. I'll give you 2. Ask for the 3rd. Just understand how to go back and forth between these 3 values. Question 3, based on the mechanics of moving average with a window identified. This is just mechanical. For example, in this time series 2, 4, 6, 8, for years 1, 2, 3, 4 respectively, the forecast for year 5, using a moving average with a window of 2, which would be the last 2, will be 6 plus 8 over 2, which is 7. And it'll be maybe a window of 2, maybe a window of 3, so it just depends. And so you have to just do the mechanics. Question 4 in forecasting, based on a 2-year quarterly time series, with only seasonal and random components. So it will be this kind of problem. You won't have these numbers, but you'll have this table. It'll be 2 years. It'll be quarterly. It'll be only seasonal and random. And I have different numbers in there. Now, the possible questions I could ask for this problem is the seasonal forecast for a quarter in year 3. Okay, and for example, for quarter 1, it will be 2 plus 4 divided by 2, which is 3. Or I could ask the seasonally adjusted forecast for a quarter of year 3, like quarter 3. Well, in this case, I sum everything 40 divided by 8, which is all of them. That's going to be the seasonally adjusted forecast for all the quarters in the future because it's stationary. Okay, those are the forecasting questions. Next is the linear programming questions, 3 questions. Question 1. Question 1 is based on the type of LP defined. For example, a product mix, ingredient mix, transportation LP. Well, the whole idea of a product mix is producing a product to not exceed capacity of resources and maximizing profit. And I'll use profit. It could be revenue, sales, or what, but it's going to be profit. Ingredient mix, purchasing ingredients to meet requirements and minimizing cost. Transportation LP, determining shipping schedule from sources to destinations that minimize the total cost of the shipping. Okay, so in other words, this is based on just understanding, describing something and knowing which it is, which type of LP it is. And I'll just do those 3. Question 2. Question 2 is based on the definitions and mechanics of the LP formulation. And so it's simply, I'll give you an objective function here, subject to a constraint set. There'll be 2 of them. One will be greater than, one will be less than, and I'll give you a mix, x equals 1, x equals 2, or something. And you put 1 and 2 in here for the objective function, that'll be 3. You put 1 and 2 in here for this constraint. Well, 1 here and 2 here is 8, 9, 10. That's 4 more than 6, so the surplus is 4. So 1 and 2 in here, 3 plus 4, what's 3 plus 4? 7. That's 2 less than 9, so the slack is 2. The slack is 2, surplus is 4, the value of objective function is 3. And so in the question, I'll give you something similar to this, and then I'll make a statement. I'll either talk about the slack, either talk about the surplus, the value of the objective function. You have to pick the right one. And notice I did all that in my head. Okay. Question 3. Based on the definition and mechanics related to binding and non-binding constraints. For example, in the product mix LP down here, and so I'm going to give you a table just like this. Different numbers, okay, and I'll give you a mix again, A equals 1 and B equals 2. So let me just go ahead and put A equals 1 and B equals 2. Resource X is binding. Why? Well, 2 times 6 is 12, plus 1 is 13, and that equals capacity. Resource Y is non-binding. Why? Well, 2 times 5 is 10, plus 2 is 12, and 12 is 1 less than 13. Non-binding. It's not equal. Resource Z is non-binding. Why? Well, 2 times 4 is 8, plus 3 is 11. 11 is 2 less than 13. Not binding. So you have to just identify what's binding and non-binding. And there'll be a table very similar to this, except I won't put those in. I'll put these up here. Okay. Topic 3, 4 questions in aggregate planning. Now the first question is based on the relationships between the pure strategies of level and chase, the variability in the demand, and the control over the inventory and labor. So remember, with level and chase, that has implications and takeaways of the variability reflected either in the labor or in the inventory, and also control over labor and control over inventory in such that you can make it any level you want. Possible questions. Inventory is independent of demand variability for a pure strategy, pure chase. Labor is independent of demand for a pure level. The most control over inventory is for pure. The most control over labor is for level. So that's the kind of questions I could ask. Question 2 is based on the relationship of production standard, and the FTE requirements. Specifically, I will allude to this equation where the number of FTEs equals the production divided by the production standard for that particular time period, where the production standard is given. For example, find the FTEs required given production standard and production level. Okay, so I give you these two and ask for this one, so you have to pick out the right ones to determine how many FTEs you're going to need. Question 3. Based on recognizing the type of aggregate planning strategy from the quarterly demand and quarterly production for a year. For example, the production is 5555, 5, 10, 15, 20, and then the quarterly demand is 4, 6, 8, and 2. That represents a level strategy, because 6 plus 4 is 10, 8 plus 2 is 10, 10 and 10 is 20. So that's 20, and that's 20. So it's a level strategy. The quarterly production of 4, 6, 8, and 2 for the demand 4, 6, 8, and 2, that's going to be chase. But also the quarterly production 5, 7, 9, and 3 for the quarterly demand 4, 6, 8, and 2, it's not the same. But notice 5 is 1 more than 4, 7 is 1 more than 6, 9 is 1 more than 8, 3 is 1 more than 2. So each one of these is 1 more than each one of these, so it's still chase. Notice the last production plan increased the ending inventory by 4 because each quarter I produce 1 more than the demand, so my ending inventory will increase. But it's still a chase demand because the pattern is this in the demand is the pattern in the demand is reflected in the production plan. Question 4. This is based on recognizing the quarterly production standard from the quarterly demand and quarterly production for a year. Specifically, determining, again, the production standard equals the production over the number of FTEs. So it's similar to above, but I do it the other way. For example, finding a standard, production standard, given a production level of the number of FTEs. And so I can give you this in all different ways, give you the numbers and within the sentence. And so you have to pick out, understand the definitions and pick out the right numbers and then do the equation. Okay, the last one is inventory. Now, question 1 is based on the relationship of the total ordering cost, which is this line right here, total ordering cost, which is D over Q times C sub O. Total carrying cost, which is this line right here, which is the Q over 2 times C sub C, and the inventory policy ROPQ, as represented in this graph. Okay, the possible relationships, and this is for the safety stock of 0. There is no safety stock. So for this problem, the possible relationships are the ordering cost here, the ordering cost is greater than carrying cost when Q is less than EOQ. The ordering cost is less than the carrying cost when Q is greater than EOQ. And they're equal when Q equals EOQ. So it's just a relationship between the ordering and carrying cost greater than and less than EOQ. And the way I ask it is this way. For example, TOC is greater than TCC for the inventory policy 3.6 and EOQ is 7. So if that's the lot size and that's the EOQ, well, that's the Q is less than the lot size, so therefore the ordering cost is more than the carrying cost. So this is pretty much how I'm going to ask it. So you'll know how to recognize the graph and the relationships. Question 2. This will be based on relationships in the equation, and this is stochastic. Q equals the mean times the inventory period. ROP, where ROP is the mean times the lead time, plus the Z of alpha, where alpha is a stock out level, the variability of the demand, and the lead time. Especially related to the cause and effect changes in the safety stock. In other words, if I say the lead time increases, what does it do to the safety stock? Well, it's going to increase it. Okay. If the variability increases, then what does it do to the safety stock? What's the result of the cause and effect in the safety stock? If the stock out level increases, then what's the cause and effect changes in the safety stock? Okay. And so I'll probably ask either the lead time, variability, and stock out or service level. Question 3. Based on the knowledge of the conditions that indicate the application of the base stock level inventory policy that includes continuous versus periodic systems and constant versus stochastic demand. In other words, I'll say which of the following is appropriate for a base stock level. Well, first of all, it's not constant demand. So I'll have constant demand. Those are wrong. That you don't use base stock level with constant demand, but you do a stochastic demand, but you don't when it's continuous. You only do it when it's periodic. So it's just recognizing the definition. That's all it is. Question 4, based on the relationship in these equations, so I have the same equations as I did up here in the question 2, but this time cause and effect changes in the inventory policy, ROPQ. So now up here, I specifically focus on the safety stock. Here, I'm going a little bit broader and saying, what implications are you going to have with changes in the inventory policy or changes in the parameters, and how's it going to be responded to? What's appropriate in the inventory policy? So the relationship between these changes with these equations up here, the different relationships, and the inventory policy this time. Okay, so that's the four. That's the 4 topics here, and also those are the questions. And so, as I said in the beginning, this is going to be primarily for, and this is open book, open notes. This exam study guide could be part of your notes to know where to find the answers and how to interpret the question. So, I hope everyone does well. I hope this helps. So between now and the next time I see you, take care.